It's Mr. Ntuli from the other side. Before we start our lesson for today, let me tell you that you are special. There is greatness within you. You just need to believe in yourself and you will make it. It's your tutor, Mr. Ntuli. Today, we will be looking at grade 10 geometry. We'll start with grade 11 theorem, which is a line from the center, and we'll do two problems based on the above theorem. Let us revise the grade 10 work. We spoke about lines, which is number 1. We also spoke about segment. We'll be dealing with more segments when we'll be doing cyclic geometry. Number 2, and perpendicular lines with intersection lines. Now, the theorem of Pythagoras, we will be using it when we are solving our first theorem, which is a line from the center. We have to remember that we said the theorem of Pythagoras is just simply says that r squared equal to x squared plus y squared. Don't forget the theorem, it's very important. And we'll be talking about some types of triangles, but one and the most important one is an isosceles triangle, which has two opposite sides which are equal. Then we can conclude that the also opposite angles are equal. If this is theta, then this angle will also be theta. And lastly, we'll be talking about exterior angle of the triangle is equal to the sum of the opposite interior angles. It means theta will be equal to alpha plus beta. We'll be dealing with these principles as we proceed. Right. Now, let us look at the terminologies that we are going to use on this chapter. Since we are dealing with Euclidean geometry, which is also known as cyclic geometry, it means it's very important that we need to have a cycle. That cycle, it has a center, which is center A in this case. Okay, now the first terminology that I want us to get familiar with is a radius. A radius is a line from the center to a circumference. It's any line from the center to a circumference. And I want you to discover what is special about these lines. Let us measure these lines and check what is their value, and then we'll be able to do a conclusion on what we can say about them. And then when we measure this line from A to J, it gives us 4.3. Again, from A to C, it also gives us 4.3. It means, what is our conclusion? These two lines are equal. Let us draw any other line and then we can make a conclusive conclusion based on our findings. Now, there's a line from center to the circumference, and then let us measure this line again. Okay, this is my line. It's also 4.3. It means now we can make a conclusion that all these lines, they are equal, and then we call them a radius. It means this is our radius. Okay. The second thing that I want us to talk about is a line segment. A line segment is very important because we will be dealing with a line segment. A line segment is any line from a circumference to another point of a circumference. Now, if we can notice, this cycle now, it is divided into two, right? It means we have a minor segment and we have a major segment, okay? And then this cycle, now is divided into two. It means we have this minor arc, you can also call this a minor arc, and then we have this major arc, okay? Right. Now, if we have a line from the circumference passing through the center and also move to another circumference, That line now, it is no longer a radius, we call it a diameter. Lastly, we'll be talking about tangent. And what I want you to know is that when we have a tangent with the radius, they always make up a certain angle. Let us discover what is the value of that angle. When we measure this angle, it gives us 90 degrees. We'll be talking more about that when we will be dealing with tangent. Just wait and follow my videos as we are. Right, guys, let us recap on the terminologies that we were talking about previously. We said we have a line segment. We'll be talking more of this line segment, or we call it a same segment. We have a radius. We have a radius. If there are more than two, we don't no longer call them radius. It's either we say radii or radii. It depends how you pronounce them. And then we have a tangent. And remember that when you have a tangent, you have 90 degrees, which is perpendicular to a tangent. But don't worry, we'll deal with that when we'll be talking about tangents. Lastly, if we have a radius passing through the center, and then it's no longer called radius, it is now called diameter. Guys, let us jump to our first theorem, which reads as follows. The line drawn from the center of the cycle to the midpoint of the chord is perpendicular to the chord. Right, let us discover on what they are talking about. Okay, we have cycle center O. It means now I need to have a line, which is a line segment, which is also known as a chord. This line, it needs to have a midpoint. It means I need to have a midpoint of this line. Right, let us find the midpoint of this line. There is our midpoint, which is T. And then our theorem, it also says that this line starts from the center of the cycle to the midpoint of the chord. Let us discover what is the angle that it forms after that. We have the angle, and oh, wow, it's 90 degrees. It means it is really 90 degrees, which is also known as perpendicular to the chord. Now, let us take this theorem now and try to prove it, because one of the questions on exams, you'll be required to prove this theorem. Okay, guys, now let us look at this question on how it is asked on exam situation. It says that prove that the theorem which states SR is equal to RT. We need to prove that SR is equal to RT. Okay, the first thing that we need to do, which is the first mark, is to do a construction. You need to construct your OT and OS, which is what, guys? Yes, your radii, because they are more than two. It means we say join radii OT, OS, and OT. Right. And then let us do some proving now. It means we have triangle ORT and triangle ORS. Okay, we need to have three things in order to prove this theorem. The first thing is that we have been given that on this diagram, O is the center of the cycle and R is a point on the chord ST such that OR is perpendicular to ST. It means if this is R1 and this would be R2, it means our R1 will be equal to R2, which is equal to what? 90 degrees. Then that is what? It's given because it's on our given statement. Number 2, I hope you can see that OR is common. OR is a common side. It's a common side. Lastly, we said OT and OS are our radii, and we've concluded that our radii are equal. It means OT is equal to OS, which is your what? Your radii. Therefore, if you can remember from grade 10, that when you prove that we have three things which are equal, then those triangles are congruent. ORT is congruent to triangle ORS. We proved by right angle hypotenuse side. Then we can say now RT is equal to RS. You can conclude that. That's how we get these 5 marks, guys. It's your first mark for construction. These 3 marks, which is summing up to 4, and your 5th mark for stating which rule you used in terms of congruency. I hope you understood, and let us proceed now to the practical examples on this theorem. Okay, guys, let us look at 4.2. We still have a diagram, and we still have to remember our theorem of Pythagoras, which is x squared plus y squared equal to r squared. And we still have to remember our right angle triangle, which is x, y, and r. Okay. Now, in the diagram, AB is a diameter with the center O. Let us look for center O. There's center O. It means AO is equal to OB and also OE. It means AO equal to OB and OE if anything happens. Right, and then D is in a point on AC such that AD equal to CD, which equal to 48 centimeter. There is AD, which is 48 centimeter, and DC is 48 centimeter again. Wait a minute. If this is a midpoint, we have a line drawn from the center of the cycle to the midpoint of the chord. Yes, continue. It will be perpendicular to the chord because we need this 90 degrees. We need this 90 degrees. Okay. Now, let us continue. Where is the point such that OD is equal to 14 centimeter? OD is equal to 14 centimeter. Okay. What is the question? Calculate the length of DE. DE. DE is an extension of OE. Remember that you said OE is a radius. Okay. How can I construct my right angle triangle? I have OD and I have DC. It means if I redraw this triangle, now this is my 90 degrees, which is D2, because I have to state that first. I need to say D2 is equal to 90 degrees. Why? Because we have a midpoint chord theorem. Okay. Then DC, there is my D, there is my C, and this is my O at the top. DC is 48 centimeter, OD is 14 centimeter, and OC is my radius. Let me call it X. If I can find the length of the radius, I can be able to find DE because I will say OC is equal to OE, then DC will be subtracted from this 14. It means my r squared equal to x squared plus y squared, which is a theorem of Pythagoras. And then what is your x squared? It's 48 squared. What is your y squared? It's 14 squared. And then you go to your calculator. And then we use a square root, which is 48 squared plus 14 squared. Right? What is our answer? 50. It means our R is 50. Remember that we were looking for DE. It means DE will be equal to 50 minus 14, which is 36. That's how you find your value of DE. I hope you understood. If you didn't understand, make sure that you replay this video and make sure that you understand. Thank you so much. Let us jump to the second one so that I'll make sure that you have understood these concepts. First thing first, read your given statement and try to do your theorem of Pythagoras. Make sure that you pause this video and try to do it on your own, and then go back and check how I did it. In the diagram, O is the center of the cycle. There is O, it means OB is equal to OA, and it's also equal to OD. OD, guys, these are the radii. Okay, and then they said AE is equal to EB, which is 6 centimeter, 6 centimeter, 6 centimeter. Wait a minute, guys. We have a line drawn from the center of the cycle to the midpoint of the chord. It means it should be perpendicular to the chord. I can just state that OE is perpendicular to AB. Why? Because we have a midpoint chord theorem. Okay? Now, I can now see my right angle triangle. And they said now DE is equal to 2 centimeter. There is DE which is equal to 2 centimeter. If the radius of the cycle is x centimeter, there is the radius which is x centimeter. Calculate the remaining value of x. Wow, okay, that is easy as 1, 2, 3. Because I will draw my right angle triangle. Okay, there is E because now I've realized that my E is 90 degrees. There is B, and then there is O. Right. If OB is equal to X, right, this is my OB which is equal to X. EP is equal to 6 centimeter. There is my EP which is equal to 6 centimeter. OE, okay, OE, I don't know the value of OE, but I know something that OD is a radius which is X. And DE is 2. Come on, yes. It means OE will be X minus 2 because the whole of this length is X and this small portion is 2. It means OE will be X minus 2. Pause this video and try to make sense of that. If I have this length which is 6 centimeter and I'm giving you this portion which is 2, then I'm asking you to find this remaining part, which will go at 6 minus 2, which will be 4. Same thing that I've done from this problem. Then I can use the theorem of Pythagoras to find the value of x. Let's say r squared equal to x squared plus y squared. What is my x squared? It's x. And then my x squared will be 6 squared. My y squared will be x minus 2 all squared. This is x squared. This is 36 plus x squared minus 4x plus 4. And my x will cancel each other. This will be 40. Transpose 40 will make it to 40. It means 4x will be equal to 40. Then divide by 4. It means x equal to 10. The numerical value of the radius is 10. Guys, this was Mr. Ntuli from the other side. I hope you understood this concept. Remember to draw a right angle triangle and make sure that you fill all the missing information so that you'll be able to answer your question. Again, you are great. You were born to be great. Believe that and run away with it. It's your Mr. Ntuli, and I will see you on the next episode. Don't forget to subscribe, to like, to share, and also comment, guys, which problems you want me to focus on so that I will be able to assist you. I love you so much, guys. You must have a wonderful day. Thank you so much.